Our next topic is productivity. How can we measure the productivity of an operation? The basic definition of productivity is the value of the outputs produced divided by the value of the input resources used. Mathematically, the productivity is defined by the value of the output over the value of the input. We'll talk about two types of productivity, labor productivity and multi-factor productivity. First, how can we define the labor productivity? First, we're going to fix the time frame, and within the time frame, we're going to compute the value, the dollar value of the outputs produced and divide it by the total number of labor hours used within the time frame. Let's take an example. Student tuition for one course at State University is $3,000 per semester. If an instructor works an average of 10 hours per week for 15 weeks for each course of 20 students, what's the labor productivity ratio in terms of the dollar value per hour? So let's use the definition of the labor productivity. Let's fix the time frame. What's the time frame? We're looking at one semester for one course. During this time frame, what's the dollar value of the outputs produced? And we're going to divide it by the total number of labor hours used. So what's the value of the output? It's the tuition that students pay. So how much tuition is paid? The tuition is $3,000 per student, and there are 20 students in one course. So the total dollar value of the output is $60,000. What's the input? What's the total labor hours? There is an instructor. She works 10 hours a week and for 15 weeks. So 10 hours a week for 15 weeks, that's 150 hours. So the ratio is $400 per hour. So that's the ratio of labor productivity. Now let's try another example. Susan Williams runs a small flat staff job shop where garments are made. The job shop employs 8 workers. During the first week of March, each worker worked 45 hours. Together, they produced a batch of 132 garments during that week. Each garment is sold for $2. What was the labor productivity at this job shop during the first week of March? So let's use the definition. What's the time frame? It's the first week of March. What's the dollar value of the output that's produced? They produced 130 garments, and each is sold for $2. So $264. Now, what's the total labor hours used? They had 8 workers, and each worker worked 45 hours that week. So 8 workers times 45 hours per worker. That's 360 hours. So the ratio is $0.73 per hour. In other words, for each labor hour they used, they produced an output that's worth 73 cents. So far, we talked about the labor productivity. When we calculate the labor productivity, we only used labor hours as input resources. But in many cases, we use more than just labor. We use machines and equipment, materials, and other services. So if you want to add all the other input resources, we can use the multi-factor productivity. So how can we define the multi-factor productivity? Again, we fix the time frame, and we're going to compute the dollar value of all the output that's produced during the time frame divided by the dollar value of all the input resources. So for example, the input resources could be labor, materials, services, energy, etc. And these input resources have different units, so we can't add them directly. So we have to convert each of them into the dollar value, and then you can add all of them. That's the total dollar value of all the input resources. Now here we see the cost of capital. What do I mean by the cost of capital? It's the interest payment a business makes to banks. Most businesses have loans, and because of these loans, they need to pay interests. And these interest payments are called the cost of capital. The cost of capital doesn't include the principal. So let's take an example. A team of workers makes 400 units of a product, which is sold in the market for $10 each. The accounting department reports that for this job, the actual costs are $400 for labor, $1,000 for materials, and $300 for overhead. Compute the multi-factor productivity. Let's use the definition. It's the ratio of the dollar value of the output over the dollar value of the input. So what's the dollar value of the output? They produced 400 units, and each of them is sold for $10. So it's $4,000. Now, what's the dollar value of all the input resources? $400 for labor, $1,000 for material, $300 for overhead. So the total dollar value of all the input resources is $1,700. And the ratio is 2.35. Now let's try another example. The details of weekly output and input for a fabrication process are as follows. Output is 600 units with a standard selling price of $50 per unit. For the week, total labor costs are 8 workers at 40 hours for the week are paid $20 per hour. Total material costs for the 400 units are $8,000. Weekly overhead is charged at the rate of 1.3 times the labor costs. What's the multi-factor productivity for the week? So again, let's use the definition. It's the dollar value of the output over the dollar value of the input. So what's the dollar value of the output? They produced 600 units, and each of them is sold for $50. What's the dollar value of the input resources? First, we have the labor cost. We had 8 workers, and each of them worked 40 hours a week. And so this is the total number of hours. And for each hour, $20 are paid. So this is the labor cost. Now, what else did you use? The material costs are $8,000. And there was the overhead, and it's 1.3 times the labor cost. So 1.3 times the labor cost, which is this. 8 times 40 times 20. So compute the numerator, compute the denominator, and divide, and you get 1.32. That's the multi-factor productivity. So far we talked about the labor and multi-factor productivities. Now, how can we interpret them? So if the labor productivity of a business is $400 per hour, that means for each hour they used, they produced an output that's worth $400. So now let's replace this with X dollars per hour. If the labor productivity of a business is X dollars per hour, what does that mean? That means for each hour they produced an output which is worth X dollars. How about the multi-factor productivity? If the multi-factor productivity of a business is 2.35, this means, let's look at the definition of the multi-factor productivity. That's the value of the output over the value of the input. And remember, 2.35 is the same as 2.35 over 1, right? So in other words, if this business uses $1 as the input resource, then it produces an output that's worth $2.35. So for each dollar that's invested into the business, they produce $2.35. That's how we interpret the multi-factor productivity. So if the multi-factor productivity is X, what does this mean? That means for each dollar invested into this business produces X, an output that's worth X dollars. So far, we talked about how to compute the productivities. And high productivity means high efficiency. And one of our goals is to achieve high efficiency. And that leads to the following question. What reduces productivity? And one of the answers is waste and inefficiencies. So in the next part, we're going to talk about how to reduce waste and inefficiencies using the concept of lean systems.